Hello everyone, so let's proceed now to intervals. So as you will later see, if you understood the inequalities, then you will also understand easily intervals because they are basically the same, but it's just a matter of notation. Okay, so let's define an interval first. So an interval is a set of real numbers that contains all real numbers lying between any two numbers of the set. So it's a set, so it's basically a set of real numbers that contains all real numbers lying between any two numbers in the set. So an example of this would be, say, -2, 3. So what this means is this includes all of the real numbers between -2 and 3. It does not include -2 and 3 because it uses this notation here, the parentheses. But if we say that -2 and 3, so this includes -2 and 3 and all of the values in between it. So this will become clearer as we progress. So intervals can also be divided into closed or open. So we will see what this closed and open means in the table below. Okay, so let's see first bounded intervals. So bounded intervals, so let's focus on the first row. Okay, so here is an example of a bounded interval. We have here the real numbers a and b on the ends of the interval. So, and we are using the bracket notation. So if we use the bracket notation on both sides, so that is what we call a closed. And we can also express it as an inequality. So in the previous lesson, we've already seen this inequality, right? So x is greater than or equal to a and lesser than or equal to b. So remember, if we use these non-strict inequalities, then we use the bracket to what do you call this? To say that a and b, the ends are included in the values. So in the graph, as you can see here, it uses the brackets on the ends on a and b. So that tells us that this set of values include a and b as well as all of the values in between a and b. Okay, so that is a closed interval type, and it is bounded. It's called bounded because we have real numbers on each side of the interval. Okay, so let's proceed to the second row. So this second row is an open interval. So it's open because of this notation right here. So what it says is it includes all of the values in between a and b, but it does not include a and b. So what this means in inequality notation is this: it uses the strict inequalities. So as we've learned in the previous in the inequalities lesson, that this does not include the values of a and b. So when we graph it, we use this illustration of the parentheses to designate that a and b are not included. Okay, so let's move on now to half open or half closed. So as you can see, this is only half closed and half open. Okay, so in the inequality notation, you can see that it is non-strict here on the a side, greater than or equal to a, and it is strict here on the b. So this means that it includes all of the values from a to b, from a, and it includes a to, and all the values in between a and b, but it does not include a b. So as you can see here, it includes a and all of the values here until you reach b, and it does not include b. Okay, because of the strict inequality here. This only x is only lesser than b, but it's not equal to b. Okay, so this next row is simply the same, but the half closed or half open is just switched to the other side. Okay, so in this particular example, the non-strict inequality is on b, and the strict inequality is on a here. Okay, so if you graph it, so this interval includes b because it's greater, x is lesser than or equal to b, and all of the values here until you reach a, and it does not include a. So all of the values between a and b, it includes b, but it does not include a. Okay, so now let's proceed to unbounded intervals. So if you take a look at the first column, here, you can see the infinity symbols. Okay, so this is the main difference between unbounded and bounded, because in unbounded you have on the ends of the unbounded interval are real numbers, but here it continues all the way to infinity. So in this case, in the first row, we have the interval a, and then it goes all the way to infinity. So it includes a, so this set includes a up to positive infinity. So in the inequality terms, this is x is greater than or equal to a. Okay, so like this. So it includes a, and it also goes all the way to positive infinity. And then we have an open interval type here. So this is same thing, but it uses a strict interval, so it does not include a here. Okay, so if we go to the switch to the other side, if we use b, and we go all the way to this, includes b, and it goes all the way to negative infinity. X is lesser than or equal to b, so lesser than or equal, so we use this notation. It includes b and all the values up to negative infinity, and basically the same thing here. So the only difference is this, like in the example above. So includes all. It does not include b. So from b it goes to negative infinity, but it does not include b, right? So here x is lesser than b. So all of the values lesser than b up to negative infinity, not including b. Okay, and we have here the entire real number line. You can see here there are no integers that bound on both sides, so it's just a continuum from negative infinity to positive infinity. Okay, so x is greater than negative infinity, and x is lesser than positive infinity. So this is the graph for that. Okay, so let's do some examples. So express the following intervals in inequality notation and graph the intervals on the real number line. Okay, so let's start. So let's answer solution. So for number 1, we have -1 and 1, right? Okay, so what is the inequality notation for this? So the inequality notation for this will be -1. Okay, so x is greater than -1. So why do we use greater than? Because this is open here, right? So it does not include -1. Greater than -1 and is lesser than 1. So as you can see here, we do not use lesser than or equal because this is open here in 1. So this means includes all the values, all real numbers between -1 and 1. Okay, so if you graph this, let's draw here. Okay, let's say this is 0, this is 1, 2, -1, -2. So to graph this, you simply do this like that. Let's make it thicker, and like that, and then this here, then draw a line here. Okay, so why did we use this again, this parenthesis symbol here? Because it does not include -1 and 1. It only includes all the values between -1 and 1. Okay, so that's it for number 1. So let's proceed to number 2. Number 2, we have 4 and that. Okay, so how are we going to express it in inequality notation? So we have x, since this is a closed, half open or half closed, it is closed in 4, so that means it includes 4. So x is greater than or equal to 4, right? So basically that's it, because it goes all the way to positive infinity here. So we can restate this too. It's also equal to x is, let's just convert it to the other side. Okay, so let's just say x is greater than or equal to 4. Okay, so it includes all the values from -4. It includes -4 because of this closed I have closed interval here, and it's closed in 4, and then it includes all the way to positive infinity. So this is the inequality symbol for that. Okay, so let's graph it. Okay, so 0, 1, 2, 3, 4, 1. Oh, it's 4. Wait. Let's move. Wait. Let's move 0 here. Okay, 0, 1, 2, 3, 4, 5, 6, and so on. -2, -3. So this is 4, right? So what we're going to do? It includes 4, so we have to use this bracket, and then let's go all the way to positive infinity. Do that. Okay, so this is the graph of this particular item. Now let's proceed to 3. So negative infinity, 0. So negative infinity, 0. Okay, 0. Negative infinity, 0. So what does this mean? Okay, so for let's take the inequality for this. So this basically means x is lesser than 0. So this is the values that are lesser than 0 all the way to negative infinity, and does not include 0 because it is open here, right? Okay, so let's graph this. Oh, wait. Graph this. Oh. Okay, so up here, 0, -1, -2, -3, 1, 2, 3, 4, 5. So have here we put a bracket here in 0 because it does not include 0. It goes all the way to negative infinity. Okay, So that is our graph for this particular item. So that's it for this video. I hope you understood this concept of intervals, because these intervals will be very useful as we go along to progress to more advanced topics in algebra. So see you in the next video.